Okay, so 33, this is from the Chapter 16 homework set. That's where you find capacitors. Shh. So we got 4 capacitors. First thing they want us to do is simplify the 4 capacitors into one. That's referred to as the equivalent capacitance. So you're going to start out by simplifying these 2 capacitors. They are in series, so we're going to redraw this circuit. So here's point A. The circuit goes like this. We're gonna simplify those 2 that are in series into one. So this simplified picture is going to look like this, and then there's point B. So this is a 20 microfarad. Down here we have a 6 microfarad. Now a 15 and a 3 in series. Remember, the way you simplify resistors and the way you simplify capacitors is reversed. It's opposite of each other. Other than that, other than how you simplify, what's true for capacitors and what's true for resistors is very similar. Just change the word current to charge, because current flows through resistors. Charge gets stored on capacitors. So simplifying capacitors in series, we do the 1 over equation. So we're going to go 1 over the equivalent capacitance is 1 over 15 plus 1 over 3. When you simplify that equation for the equivalent capacitance, we get 2.5. So this is 2.5 microfarad. All right, now here I'm going to shrink these guys down so we have room. Shrink that. Okay, so now we're going to simplify again. So here's point A. So now what are we going to simplify? Those guys. Did I make a mistake? Where? Is it right? Okay, good. Well, hey, I'm glad you. So 2 point, we're good? I make mistakes. That's good? Okay. All right, so now what we're going to do is we're going to simplify these guys. Those 2 are in parallel. The way you simplify capacitors in parallel, you just add them up. So a 2.5 and a 6, that's going to be 8.5. And then here is the 20. So this is point A. Over here is point B. 20 microfarad. Okay, so now we got 2 capacitors in series. So we do the 1 over equation. 1 over the equivalent, it's going to be 1 over 8.5 plus 1 over 20. And so when you do that algebra, everything simplifies down to 5.96 microfarad. Okay, and then that's the answer to the first question. So there's point A, there's point B. Okay, second question, so B. Calculate the charge on each capacitor if a 15-volt battery is connected across points A and B. So you're going to see this in a lot of the homework problems where you got these points here, A and B. So all those are points where you can hook up whatever you want. So for this problem, they're saying we're hooking in a battery. A 15-volt battery gets hooked across those points, right? So we can put this in all the diagrams. So we're adding a battery, 15 volts. We'll put it in all the pictures. 15 volts. 15 volts. All right, now calculate the charge on each capacitor. So for these problems, just like resistors, what you do is you start with your most simplified picture, right? So we're going to start down here with our most simplified picture, and then we're going to work our way back to the original picture. So we're going to go to this picture, then we're going to go to this picture, and then we're going to go to this picture, right? Circuitry is all about simplified pictures. Now, simplest of all situations, 1 capacitor with 1 battery. Hey, if that's a 15-volt battery, there must be 15 volts across that capacitor, right? 15-volt battery means what? Positive plate is 15, negative plate is 0. So how many volts at point A? 15. How many volts at point B? 0. So how many volts are across the capacitor? 15. So now what we do is we use the definition for capacitance. Capacitance is charge per volts over voltage. So the charge is going to be capacitance times voltage. So we're going to go 5.96 microfarad. Just leave that micro, okay, and then 15 volts, okay? So this is going to come out as 89.5 microcoulombs, right? Because a farad right here, what's a farad? A farad is a coulomb per volt, so the volts cancel, and then you have microcoulomb. All right, so we figured out that the charge on this guy is 89.5 microcoulombs. So what's going to be the charge on this guy? 89.5 microcoulombs. What's the charge on this guy? 89.5 microcoulombs. It's the same as resistors, man. If these were resistors, if you found the current through the simplified resistor here, then you found the current in those. Charge on capacitors in series is the same, okay? So I found the charge on this guy, which means we now have the charge on those guys, okay? Now, so actually we know, we've already answered part of the question. We figured out the charge on this guy. What we're trying to find is the charge on all the guys, 89.5 microcoulomb. Now, how do we figure out the charge on these guys? Well, if we want the charge on like this guy right here, here's what we're going to do. We're going to go charge equals capacitance times voltage. So the capacitance is 2.5 microfarad. But what do we got to figure out? The voltage. How many volts is across this capacitor? So how do we do that? The easiest way to do it is go to this guy. Who is this guy that I'm circling here? Who is he? This guy is these guys, right? So if you can find the voltage here, if you can find the voltage across this guy, then you found the voltage across these, right? So how do we find the voltage across this guy? Just rearrange the capacitance equation. Voltage is going to be charge over capacitance, right? And we have both. The charge is 89.5 microcoulombs. The capacitance is 8.5. So you divide those out, and we figure out that the voltage across this guy is, what is that going to be? 89.5 divided by 8.5, 10.5. So this circle here is 10.5 volts. So what's the voltage across this guy? The delta V across this guy is 10.5. What's the delta V across this guy? 10.5, because voltage in parallel is the same. I always like to do this. If this is a 15 volt battery, that means 15 and 0. So look, how many volts here at point A? 15. How about over here at point B? 0. So look, when we cross, when we go from point A over to this point, we're going to lose some volts. In fact, we know it's 10.5. So that's going to bring us down to 4.5. This point right here has to be 4.5 because we lost 10.5. And then the voltage across this 20 has to be 4.5, which you could figure out from this picture. And that brings us down to 0. It's like a puzzle. Okay, so anyway, this is 10.5 volts right there. So you multiply that out. The charge on that guy is times 2.5, 26.3 microcoulombs. 26.3 microcoulombs, which means what's the charge on this guy? 26.3 microcoulombs. What's the charge on this guy? 26.3 microcoulombs, because who is this guy? This guy is those guys. Okay, finding the charge on the 6 microfarad guy. So just change the 2.5 to 6, and then the voltage is 10.5. So that's going to come out, you're going to go 6 times 10.5. That's 63 microcoulombs. So the charge on this guy is 63 microcoulombs. The charge on this guy we already figured out. The charge on that guy is 89.5 microcoulombs. Okay.